So to start off is we have to start with the improper integrals first. And we're going to be discussing two types of improper integrals. So one is the improper integral having an infinite limit of integration. And then the other one is the improper integral that has an infinite discontinuity. So let's try to look at the two types of improper integrals, and then let's try to understand what's the difference between the two types of improper integrals. So to begin with is we start off with the improper integrals with infinite integration limits. So we have three properties. So as you can see, if f is continuous on the interval of a to infinity, interval of negative infinity to b, and then negative infinity to infinity. So notice that we always have an infinite limit of integration in the problem or in the situation. So if you have infinite limits, so what we do is from this format is we're going to remove the infinite limit by applying your knowledge in your derivative, your differential calculus. So that will be the limit from b approaches infinity, and then you'll replace the infinite value with a b parameter. So I think that's how you deal with the improper integrals. So you just take out the infinite limits and make it into this format. So same goes here. So the lower limit is now the negative infinity. So you transform it into this format. Then you replace the lower limit with another variable. So if you have negative infinity to infinity, so as what we have discussed before, properties of definite integral. So you can create midpoint, or let's say an in-between limit of integration for you to be able to separate the two infinite limits. So let's say from negative infinity going to c, and then from c going to infinity. And then after this one is the first one is you're going to apply the second property, and then the other term is you apply the first property of the improper integrals. So this will give you the limit of let's say a to negative infinity. So this becomes from a to c f of x dx. And then the other one is applying the second, the first limit of integration. The first improper property. So this becomes c going to b. So you have to write the limit approaches. So limit of b approaches positive infinity, and then from c to b f of x dx. So after you apply the properties, you apply these formulas, or you take out the negative and positive infinite limits. So the next process is you have to integrate manually, which is kibawa na mo ana. And then after applying the limits of integration, after integrating is you apply the limits of integration, and then you apply the limit of b or a approaches infinity depending on the problem. So in the first two cases, so we have two types of answer that we can expect from these improper integrals having infinite limits. So one is, for example, the limit does not exist. So the improper integral converges. All right. bali. So if the limit exists, so the improper integral converges. And then if the improper integral doesn't have a limit, or meaning the limit is not existent, so it's still infinite or negative infinity or zero, so meaning it's diverging or it diverges. So converging limits, I mean converging improper integrals, so those are the improper integrals having an exact value of their evaluation, diba? So for example, you get 1, you get 2, or any value, that is what a converging improper integral looks like. For diverging integrals, so the answer for your improper integrals are still negative infinity, positive infinity, or 0, because the limit does not exist, or it's not exact, diba? Okay, infinite limits, I mean infinite answer, so you don't know up until which point the answer is because it's in infinity. So especially for negative infinity also. All right, so let's try to understand what I'm talking about. So let's go on to the first example. So this is what an improper integral looks like, having infinite limits. So again, as per formula, is we're going to take out the limit first. So since this is the upper limit of your improper integral having the infinite limit, so this becomes the limit. So applying the first property, I guess. So b is the upper limit, so approaches infinity. And then you're going to have 1 to b. And then dx all over x. So next is you're going to manually integrate. So you know the integral of dx. So this becomes as the limit of b approaches infinity. And then you're going to have ln of x from 1 to b. And then applying the upper and lower limit. So you're going to have the limit from b approaches infinity. We're going to have ln of b minus ln of 1. Right? So I think ln of 1 is equal to 0. So ln of 1 is equal to 0. So what is left is just the limit of b approaches infinity, ln of b. And then you apply this particular format. And so as ln of b, so you have ln of b, then b approaches infinity. So what will be the answer? So if you try this one in your calculator, so to give you an idea on how to get the final answer. So if you try, let's say ln 9, so you're going to have 2.19, diba? So let's try ln 9. So this gives you 2.20. So let's say ln 99. So ln 99 gives you 4.60. What if I put a lot of 9 sa inyong equation? So ln, let's say 99999. So ang butas calculator nako is 29.93. So notice that the value of your ln is increasing as you plug in more numbers. So the ln of b as b approaches infinity is still infinity. And since your answer is not existent, or the limit does not exist, so this one is diverging, or it diverges. So C0 kayo, no? So you just have to evaluate this one manually. Okay. murag dili kaya sa calculator mag-solve og improper integrals. Alright, so questions or clarification so far? Okay, so I guess there's no question. So let's try to move on to the next example. So this is the solution. So this 0 here is coming from ln1. Alright, so for the second example, so the infinite limit is still on the upper limit. So this becomes the limit of b approaches infinity. And then the integral from 0 to b e to the power of negative x dx. So evaluating the integral, so this gives you e to the power of x, and then of course you your du. So if we try to make this as a u sub, so let u is equal to negative x, du is equal to negative dx. So this becomes negative du is equal to positive dx. So this is negative e to the power of negative x, and then you apply the limits is from 0 to b. So this gives you the limit of b approaches infinity, and then you have negative e to the power of negative b, and then plus e to the power of 0. So e to the power of 0 is equal to 1. And then e raised to negative b. So if we're going to try to evaluate this one, so if we're going to try to plug in negative e raised to negative, let's say 99, or you start off with 9 first. So to see the pattern if the it approaches negative infinity or it approaches 0 or so on and so forth. So let's try to see. So negative e raised to negative 9. So this gives you a very small number, which is negative 1.23 times 10 to the power of negative 4. What if I plug in e to the power of negative 99? So this gives me a lot smaller value, which is negative 1.011 times 10 to the power of negative 43. So notice that the decimal is increasing. So meaning the value is getting smaller. So if I plug in e to the power of let's say so many nines, so I can say that I can just make this one equal to 0. So what is left is just equal to 1. And then your improper integral converges because the answer or the value of your improper integral is exact, or it exists. It is equal to 1. So again, e raised to the power of 0, if you try to calculate this one, it's equal to 1. For any number raised to power of 0 is equal to 1. Okay, and for the first term is for this explanation here. All right, so questions or clarifications? So this is the solution. Okay, so let's try to evaluate this one. So this particular term here is we're going to be involving a topic coming from your um, differential calculus, which is L'Hopital's rule. So the same process. So we need to take out the infinite limit first. So b approaches infinity. Then this becomes from 1 to b, and then 1 minus x e to the power of x dx. All right. So how to take the derivative, I mean how to take the integral of that particular integrand is you're going to use integration by parts. So notice that this one is algebraic, this one is exponential. All right. So again, take the easier term as your derivative, and then so this one is 1 minus x, and then du is just equal to negative dx. So dx is equal to negative du. Or if you don't want that one, so ito sa ko na. So v, ito lang erase kay it's integration by parts eh. So sa'yo pa kung kuan. So v here, I mean dv is e to the power of negative x dx. So getting the integral of e to the power of negative x, so this gives you negative e raised to negative x. So uv minus v du, so this gives you 1 minus x, then negative e to the power of x, and then minus the integral of v du. So negative e to the power of x, and then du is negative dx. Then I'm going to have, so limit approaches b to infinity. All right, so this gives me the limit of b approaches infinity. So 1 minus x, and then negative e raised to the negative x. Then I have negative e to the power of x dx. Okay, so evaluating the last integral, so b approaches infinity, and then this is 1 minus x, then negative e raised to negative x, and then this is negative e raised to the negative x, then that will be the integral. So evaluating is, if we try to distribute this one, then we try to distribute this one also. So this gives you the limit of b approaches infinity, and then you're going to have negative e raised to negative x, and then you're going to have positive x e raised to negative x. Then this one is positive e raised to negative x. So this is eliminated, and what is left in the integral is now the limit of b approaches infinity, and then x e raised to the power of negative x. Then you apply the limits of integration, which is from 1 to b. Alright, so applying the limits of integration, so you're going to have the limit of b approaches infinity. Then for the first one is you're going to have x, and that will be rather b. B e raised to the power of negative b, and then minus e raised to the power of negative 1. So in fractional form, this becomes b approaches infinity, then b all over e to the power of negative b minus 1 over e. So notice, so why do we need to use L'Hopital's rule? So as you notice here, if you try to remember the topic coming from your differential calculus, so if you try to evaluate the limit of this function here, so notice that it's an improper, what do you call this in your derivatives? Gani, kalimot ko sa term ato. Basta, the term here is, it's ito yung term, kalimot ko. Basta na siya term ana nga, you can determine that this one is an improper integral because you are dealing with this kind of terms. So I think the proper term for this one is, I think, indeterminate forms. So if you try to evaluate this value here, so if the answer is 0 over 0, or the answer is infinity over negative infinity, or let's say the answer is negative infinity to infinity, so those are your indeterminate forms. So that's why we need to evaluate the first term using L'Hopital's rule. And if you have forgotten what this rule is, so again, if you have this term here, so let's say x approaches infinity, then you have f of x over g of x. So what we need to do here is we're going to get the derivative of the numerator and denominator. So by formula, this looks like this equation. So f prime of x, then the other one is g prime of x. So what we need to do is we're going to get the derivative of b, which is a constant 1, and then get the derivative of e to the power of negative b, which is the same gyapon, di ba? So asa may itong butang, so mga space. So this becomes the limit of b approaches infinity. So again, by L'Hopital's rule. So this becomes 1 all over e to the power of negative b. Then the other one is 1 over e. Okay, so if you try to plug in the infinite limit now, so this gives us a value of 0 because negative infinity, e to the power of negative infinity is a very small number, di ba? and then 1 divided by a very small number. So murag sa may labas ana niya. Diba? So it approaches 0, diba? Kay it's 0. It's a very small decimal. So if you try to evaluate this one manually, so try to plug in 1 divided by e raised to a very small number, 9999999. So this is approximately 0 na siya. So the answer for your improper integral is just negative 1 over e. So of course, you only apply the limit kung asa ang unknown parameter, di ba? Which is the b parameter. So the right hand side is, the right term is, we don't have any b parameter. So muna siya labot sa pag-apply sa limits. Alright, so do you have questions? Okay, why question? Kaya nagbibog? Hello, okay ra mo diya? Okay, so wala may kuan. Okay, so let's proceed. So ato sa lang gutom kay pang last naman sa ning nga klase. So this is the solution. So take note that in this particular portion, so this is where the L'Hopital's rule was applied. So the derivative of the numerator is 1. Derivative of the denominator is still the same. And evaluating the limit, so it gives you 0. So what's left in the equation is just the right hand side. So this is the answer. Alright, so murag sisi rin ninyo kay kibaw naman mo kung saan pag-integrate, and what's new here is the infinite limits lang. The infinite and the negative infinite limits. Okay, so next is if we have a lower and upper limit of infinite limits sa inyong integrals. So what you need to do here is we need to split this one into 2 portions so that we can evaluate this one easily. So you may have it as negative infinity, then you stop at 0 first. And then plus 0 to infinity, e to the power of x, 1 plus e raised to 2x dx. So since both terms have the same function, so you can integrate this one isolately first. So e to the power of x, 1 plus 2x. So this looks like an arctangent formula. A squared plus u squared, di ba? So a squared is equal to 1, a is equal to 1, u squared is equal to e raised to 2x, and then u is equal to e to the power of x, and then du is equal to e to the power of x dx. So e to the power of dx is your du. This one is a squared plus u squared, so you're going to have an arctangent equation. So by formula, this one is 1 over a arctangent u over a. So we don't need to put plus c because we are evaluating a we are evaluating an integral with limits. So pwede ra walay plus c. Right, so this one is just the integral of arc tangent. So u over a, so that's e to the power of x only. So from negative infinity going to infinity, then plus 0 to infinity. So bali day. So sayo, wait sa ha. Ano magpabalik today. So this gives me arc tangent e to the power of x. So negative infinity to 0. And then plus arc tangent e to the power of x from 0 to positive infinity. Okay, so we apply the limits of integration. So again, so since this one is e to the power of x, so you try to bring outside first the limits of integration. So this becomes negative infinity, and then this one becomes arc tangent e to the power of x. Ito nun. It's so e to the power of x, then this one becomes b to 0. Then the other one is limit of b approaches infinity. So this can be a because it's the lower limit. Then the other one is b. So arc tangent e to the power of x, then from 0 to b. Alright, so if we try to plug in arc tangent e raised to the power of 0, so arc tangent 1, because e raised to the power of 0 is 1. So if you try to plug in arc tangent 1, so it gives you 45. So marag dili kay siya nice tanawon, so try to convert your calculator to radian mode and then plug in arc tangent 1. So it gives you pi over 4. Alright, so again, arc tangent, so you try to plug in the equation, so I'm going to put it here lang sa yung watay space. Dili lang sa ubos lang. So arc tangent e raised to the power of 0 and then minus the limit of a approaches negative infinity and then arc tangent e to the power of a. So this is the first term. So plus the second term. So lower limit is the 0 and then upper limit is the arc tangent. So limit of b approaches infinity, arc tangent e to the power of b, and then minus arc tangent e raised to the power of 0. So again, you try to plug this one in radian mode, arc tangent 1. So this gives you pi over 4 minus the limit of a approaches negative infinity. Then arc tangent e raised to the power of a. and then plus the limit of b approaches positive infinity, arc tangent e raised to the power of b minus pi over 4. So notice if we try to combine the terms, so pi over 4 will cancel out, positive pi over 4, negative pi over 4, and then evaluating the limits, so e to the power of negative infinity. So if you try to plug in a very big number to let's say negative 99,9999, so it's 0, diba? So arctangent 0 will also give you 0. So e raised to the power of a very big number. So medyo mukuan siya, math error siya, di ba? So e raised to the power of 9. It's a very big number. So arctangent, so a very big number for arctangent. So it will give you a small number. So the final answer for this one is, I think if you have a very big number for arctangent, so it will give you the same value. So sa calculator, it's 1.57. So that will be pi over 2. So sa answer na ko dire sa solution, so this one is 1.57. But the answer in the reference is pi over 2. So again, if you try to put, so let's say e to the power of 9 first, so it will give you 8,103. So if you plug in e to the power of 99, so it will give you a very large number also. So e to the power of 9999. So math error na siya. So let's say the limit of your e is up until 99 only. So arctangent for this answer is pi all over 2, given in the calculator. Alright, so questions? Alright, so wala question kay nasabtan. So this is the answer. I mean the solution coming from the reference. So you have to break it down into two parts and then evaluate. You have to evaluate two improper integrals for this one. So the first two terms is coming from this term here. The other two terms is coming from this portion here. Alright, so let's now go to improper integrals with infinite discontinuities. So you have to understand that the limit will be discontinuous at some point. So meaning that particular integral will give a how do you call this one? It will give you a indeterminate form for your answer. So meaning it will be divided by 0. It will be the equation will cancel out and it becomes 0. So that's what a discontinuous interval looks like. So for example, if you have 3 minus x dx, and then let's say you have the upper limit as 3, so it is discontinuous at the upper limit because when you try to evaluate this one, so it gives you 0, diba? So it doesn't give you any value anymore. So that's one example. All right. So let's say your limit is discontinuous at b. So that's why when we try to evaluate your limit, so the limit on the left hand side, that's why it's b minus. So that will be what is included in your evaluation of your integrals. So let's say your lower limit is discontinuous, or the lower limit is discontinuous. So we take the limit as a approaches on the right hand side. So that's why it's a plus. Right? So maragmura na siya. So meaning if it's discontinuous at the lower limit, so meaning what you need to include in your limits is the right side of the lower limit. So if it's discontinuous at the upper limit, so meaning what you need to include in your limits is the left hand side of the upper limit. So that's why the upper limit is b minus, the lower limit is a plus, meaning the right hand side of a on the b side is on the left hand side of b. All right, and then we also have the same scenario for earlier. So you can split your improper integral into two portions. So also the same as earlier. So you are going to deal with two answers or two cases for your improper integral. So if the limit exists, so the improper integral is converging or it converges. So otherwise, it diverges or it is diverging. So other references, they call it convergent, divergent, di ba? Marag pina salida. All right, so let's try to understand what this infinite discontinuous improper integral looks like. So we go to an example. So I'll just give you the solution right away because this is a bit complicated. So the integrand has an infinite discontinuity at x equals 0. So as shown in the figure. So you can evaluate the integral as shown below. So it's discontinuous at the bottom part at the lower limit, because if you try to plug in 0 here directly, so that's one way of evaluating where the limit is discontinuous sa inyong improper integral. So if I try to plug in 0 on the denominator, so I'm going to have the cube root of 0, and then 1 all over 0 is tawagan na kanang indefinite, diba? So if I try to plug in 1, so cube root of 1 is still 1. So I'm going to have a value for this one. So meaning this one is continuous. This one is discontinuous at the lower limit. So that's why we apply the formula. So again, by formula, this becomes the limit. So b lang ang gamit niya, but pili po siya a. The limit of a approaches the 0 plus, and then you're going to put here baliday. It's so this one is c. Then this becomes c going to 1. And then you're going to have dx all over the cube root of x. In this case, gamit sa reference is B. But according to the formula, so since the formula is using C, so C approaches something. So that's why we're going to put C lang sa. The next is you try to get the integral of cube root of x, diba? So this give you this answer. So x to the power of 2/3, because this one will give you the integral of x to the power of negative 2/3, diba? Sakto? And then plus 1, so that's ito na pa-calculator. Basin sa'yo niya itong answer. Mag-save lagi niya ang answer na ko, no? So it should be 1/3, eh? So this should be 1/3. No, not 2/3 man siya. Save niya ko ang kan. So this should be 1/3. So if you try to evaluate this one, so this will give you x to the power of 1/3 all over 1/3. So this will give you 3 cube root of x. So upon integration, so mag-sayop na siya. So let's try to correct this one na lang. So this will give you the limit of c approaches 0 on the right hand side. Then you're going to have 3, and then multiplied by the limit of integration, which is cube root of x, then from c to 1. So you're going to have the limit of c approaches the right hand of 0. So this will give you 3 times the cube root of 1, which is just 1, and then minus c to the power of 1/3, or the cube root of c. Alright, so applying the limit as c approaches 0 on the right hand side, so this will give you 0. So pwede ra po siya, dili nyo i-consider ang right hand side, just plug in 0 directly in the limits. So the final answer is 3. So kaning plus sign there is 0 is that it's only indicating that what you need to include in your evaluation is from 0 and then going on the right hand side of 0. Okay, it's discontinuous at 0 man. So pasabot ana, if you try to plug in values lesser than 0, so meaning the answer will be indefinite, or meaning di siya mo give og value for your improper integrals. So I think one great example of this one is kanang mga asymptote, di ba, kanang marag a certain limit lang ilahang mga values. Yeah, at some point they are discontinuous at some portion, or let's say a parabola. So na point nga dili sila na mga values na dili mo give og data sa inyong x and y plane. Right, so let's proceed to number 2. So again, the example is still discontinuous at the lower limit, because if you try to plug in the lower limit in the denominator, it will give you an indefinite value. So for 2, so it's okay because 2 raised to 3 is 8. So meaning if you try to continue with the proper solution, so it will give you an answer good. But for 0, so even though if you try to integrate x cubed, so it's still 0, diba? So meaning it's discontinuous at 0. So you again apply the formula, limit of c approaches 0 plus 0 on the right hand side, then the integral of c going to 2, then dx all over x cubed. So this is the integral of x to the power of negative 3 dx. So the integral for this one is x cubed, x to the power of negative 2, and then negative 2. So this gives you the limit of c approaches 0 plus. So you have 1 all over negative 2x squared, then from c to 1. So next is we try to apply the limits of integration. So this is from 0 plus, then you have negative 1 all over, so 2, so this is 2 there, this is not 1 there, 2, this is 2. So this is 8, and then plus 1 all over 2b squared. So if you try to evaluate the limit of b approaches 0 plus, so if you try to evaluate this one, so the answer will be infinity. So of course, kung ano infinity man siya, so try to research why it's infinity as part of your learning process also. Okay, base niya, na-board na mo? So try to evaluate why this term here is infinity. The answer is infinity. Alright, so this is an example for your problem set, but I won't be giving you this one as a problem set, but you can solve this one on your own, and these are the answers for the corresponding items. So to give you a break from problem sets, so this is the problem set that I'm going to give you, but I won't give it to you, so just solve it on your own. These are the answers for the different items. So these are the other examples there. So this is for example number 3. And then this is for example number 4. So alright, so I think that's for the improper integrals. So let's proceed to multiple integrals. So this will be just a short discussion. So for multiple integrals is that, for example, you are given this. So multiple integrals is you're going to have multiple snakes in your equation. And then depending on the number of snakes that you're going to have, then that's the terms that you're going to have also. So dx and then dy. So it also corresponds to this one. So how do you evaluate multiple integrals is you evaluate the inner integral first, so meaning you start off with dx and then this limit of integration right here. And then the next portion is you're going to determine dy, then dy limits as well. So for example, we evaluate first with respect to x. So this is just it looks like a partial integration, or let's say a partial derivative coming from your partial derivative. So the concept is more likely a partial derivative, but we are just partially integrating lang, so the opposite of your partial one. So if we try to evaluate this one, so we're going to have from 0 to 6, and then the first one is, so integral of 27, that will give you 27x. Negative x squared, this gives you negative x cubed over 3. Then since this one is you don't have any x here, so this becomes negative 1/2 xy squared. Then applying the limits from 0 to 3 and then dy. Diba? So dali na kayo siya. So applying the limits from 0 to 3, so this gives you from 0 to 6, so 27 times 3, then minus 3 cubed over 3 minus 1/2 times 3 y squared. And then the right hand side is 0, so 27 0, then 0 over 3, then 1/2 times 0, so everything is 0 on the right hand side. So this is dy. Or if you want to show your solution para maklaro jud nako sa exam, so you can just also show it as well. So 27 times 0 minus 0 cubed over 3 minus 1/2 times 0 times y squared. And then this is dy. So again, everything on the right hand side is equal to 0. So 27 times 3, so that will give you 81. Sakto ba? 81. So 81, and then minus, so 3 cubed is 27 divided by 3, that will give you 9. And then 3/2 y squared, and then you're going to have dy. Then from 0 to 6 again, 81 minus 9 is 72, so this gives you 72 minus 3/2 y squared dy. So since you are now left with this one, so you can now evaluate the integral with respect to y now. So this will give you 72y, and then minus 3/2 times y cubed all over 3. And then applying the limits of integration from 0 to 6. So cancel out 3, so you have 72y, and then minus y cubed over 2 from 0 to 6. So 72 times 6 minus 6 cubed over 2, and then you're going to have on the right hand side, that will be 72 times 0 minus 0 cubed all over 2. So the right hand side will give you 0. 72 times 6, so you can use your calculator. 72 times 6 is 432, and then minus 6 cubed all over 2, which gives us the final answer of 324. So you have to manually integrate these topics because again the calculator cannot evaluate multiple integrals. All right. So this is the solution. So napay triple integral, so I'm going to show you directly the solution. So again, if we try to evaluate this one, so try to evaluate the inner variables first. So inner going to outer. So this is the first evaluation with respect to z, and the next is with respect to y, and then lastly is with respect to x. So again, you have to manually integrate this one because the calculator can only evaluate one integral. Yeah, especially ang multiple integral since magpatong-patong pa ang mga variables for the next integration step. So magdili kay siya kaya i-calculator jud. So probably siguro sa last portion dire. But for the other portions, so murag medyo dili kay mo ka directly og apply sa calculator ana. Alright, so this will be the problem set again for your multiple integrals. So again, I won't be giving this one, but you can solve it on your own, and these are the answers. So kani mga red one, so muna siyang answers for your multiple integrals.